Guys, day 90 of the 100 Days of LeetCode. We got a medium problem. It's first and last. Find first and last position of element in sorted array. Let's do it. So we are given an array of integers nums sorted in non-decreasing order. We want to find the starting and ending position of a given target value. If target is not found in the array, we want to return -1, -1. You must write an algorithm with O log n runtime complexity. What does this mean? We must write binary search. That's what this is telling us. Cool. So, example 1. We're looking for 8. Well, the first instance of 8 is the third index. The last index of 8 is the fourth index. So that's what we return. Here, of course, we do not have 6, so we return -1, -1. And example 3 is an empty list. Again, we return -1, -1. There is a situation that we could have here that isn't covered in our examples, and that's if there's only one instance of our target value. Then in that case, our output would just be a list of the same index, right? So it'd be, if our only instance of the target value is index 3, we're just returning a list of 3, 3. Okay, that's the one thing that isn't covered in these examples. And of course, there's situations where, you might have, 5, 6. A bunch of different instances of that, and in that case, yeah, you're still returning the first and the last. So these numbers are not necessarily, next to each other. Okay, so the first thing we need to do is we need to just create a result list, and that's just going to be we're going to initialize it to -1, -1, because at the end, this is just what we're going to be returning. Okay, so we got to do some stuff here. All right, basically, if the stuff that we do produces no results, then this is just what's going to be returned, -1, -1. That's what we're supposed to do. If target is not found in the array, return -1, -1. Okay? Now, I said we're going to be doing binary search, but how exactly are we going to be doing that? Well, we're going to be doing 2 different rounds of binary search. The first round is essentially looking for the first instance of the target value, and the second round is going to look for the last instance of the target value in the array. Now, we're doing it twice, but of course, with runtime complexity, we drop constants. So just because it's, the actual function would be 2 log n, that doesn't matter. It's still O log n, right? So that's how we write an O log n runtime complexity algorithm for this. Okay, so the first thing we're going to do, of course, binary search, we need low, we need high, okay? So high is just going to be the length of nums, -1, of course. And then binary search, this is pretty straightforward. I've done a lot of binary search problems. We do low is less than or equal to high. We find our mid, and the way we do that, we say low plus high minus low. It's in Python, so we need to do integer division. That's how we find our mid. Okay, and just for, just so we know exactly what we're doing, here is we're looking for first instance of target. That's what this while loop is doing. So we're trying to find our first instance of target. So the first thing we do is going to be the same thing as in normal binary search. We're just going to say if nums mid is equal to our target. And then we have to do another check, right? Because just because we found our target doesn't mean it's the first instance of our target. So what we're going to do here is we're essentially going to say, okay, well, if our nums mid is equal to our target, we have to check whether or not it's the first instance. So how do we do that? Well, the first thing we do is we want to say if nums is not equal to, if mid is not equal to 0, okay, and nums mid -1 equals target, well, then we haven't found our first instance. The reason why I just can't say if nums mid -1 equals target is because, of course, we want to avoid any potential index out of bounds exceptions. So if mid is 0, then this would, our computer would throw a fit with this. But once we do that check, we can now check this, okay? So if we enter this if block, that means we haven't found the first instance. So what we're going to do is we're just going to treat it as, needing to decrease our high. So our high is now going to be mid -1, right? And of course, the corresponding else block here would be to set result list index 0 equal to mid. Okay, and we want to break this loop, right? There's no point going on with this loop. Now the elif statement, excuse me, for this if, got a lot of nested ifs here, just gotta watch that. So what we want to check is if our nums mid is greater than our target, well then this becomes like normal binary search. We need to again just decrease our high, right? And the else, which would of course be our nums mid is less than our target. In that case, we increase our low, right? So this, at the end of this, there's two situations. One is a situation where result list isn't in the array, and then nothing happens, and then we pass through our second one, nothing would happen there either, and then we return -1, right? Because this would be -1, -1. The other situation is, of course, we found the first instance, and then we're just setting that equal to whatever the mid was in this particular, 3-line block of code. Okay. Now we're going to need low and high back to their regular values, or not their regular, their starting values. And now we're looking for last instance of target. Okay. And we're going to do, well, low is less than or equal to high, again, because it's binary search. Again, we set our mid, low plus high minus low, integer divided by 2. Same thing up until now if nums mid equals target, except now we need to reverse this logic. So instead of if mid not equal 0, we're going to do if mid not equal to length of nums -1 and nums mid +1 is equal to target. So what we're checking for here is basically, we want to make sure we're not at the last index, because if we are, we'd risk an index out of bounds exception with this mid +1. And if we're not at the last index and we want to check the number immediately after it, and see whether or not that is a target value. And of course, if it is, well, we need to do the opposite of what we did here, right? We want to increase our low to mid +1. Okay, and then same thing here, except of course we're indexing at 0. If we're in this else block, that means we found our target, and we can just set it to index 1 is equal to our mid, right? So the second value of our result list, we're changing now, okay? And now, it's the exact same thing as what we wrote above. Right? If our nums mid is greater than our target, we have to lower our high value. And if we enter this else block, which means that our nums mid is less than target, we need to, of course, increase our low. Okay? And then we can return result list. Okay? So let's go through it again. We initialize our result list to -1, -1. This do stuff here is old. We don't need that. We do binary search, so we need to set low to 0, high is equal to length of nums -1. We say, well, low is less than or equal to high. We do binary search. This binary search is looking for the first instance of target. And then we need to look for the last index of target. So we do the same thing. We set low and high. We do another binary search is equal to, to find the last instance of target. And then we can just return our result list. And let's submit the code. Let's see if I messed up. And I didn't mess up. Okay, that's perfect. So that was day 90 of the 100 Days of LeetCode. If you guys liked that, we got another 10 days to go. Please like, subscribe, and we'll see you tomorrow. Take care.